Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Greg Jones, founder and CEO of Montgomery Technologies. It's about all things wireless in commercial office buildings. The network layer is vital infrastructure for enabling new technology in buildings, and this episode demystifies technologies like DAS, Wi-Fi, 5G, CBRS, and more. Then Greg provided the decision tree for how to think about which networks to apply in different situations. So please enjoy. Hey, Greg, welcome to the show. Can you introduce yourself?
Thank you, James. Thanks for having me. My name is Greg Jones. I'm the president of Montgomery Technologies. We are a technology provider in the commercial real estate space and have been doing this for almost 20 years. Our 20-year anniversary is going to be next year.
All right. So 2003 is when you started it. What were you up to before 2003?
I started out in the shipping business, which I spent about 10 years doing that right out of college, traveling predominantly through Asia. And sort of my key things learning the business back in those days was I would play golf and I would be able to drink beer. And that was sort of how I endeared myself with my colleagues and our clients. And that was sort of my role, and evolved from there to working for about 10 years doing it. It was fascinating. But what I found was the .com thing was happening all around us, and I was in San Francisco, so we were sort of at the epicenter. And I transitioned out of shipping into technology, and I went to work for a property management software firm. And we were working on sort of kind of in that transition from DOS to Windows, and then using the internet to pull information from properties. So we had a relational database and a bunch of Sybase engineers, and we were pulling information predominantly from multifamily users back to corporate, allowing them to run reports and manage properties more efficiently. So that was my first real introduction to technology, and I was in the business development role there, and we ultimately sold the company to RealPage.
Thanks for that background. One of the things I thought of while you were talking there is that I once had a play golf and drink beer role in one of my jobs. When I was a early graduate, I was a ringer in golf and got to go on all these different golf outings in the middle of the afternoon when no one else did, just because I could shoot, a good score. The sales guy really liked me and took me under his wing so I could improve the foursome score. So I have never been a salesperson, but I've played that role once or twice in my life.
I had the unfortunate task of teaching both the president of my company then and the executive vice president how to play golf.
Oh God, that sounds awful.
They would want to go at lunch to go hit balls. So I would go over there and teach them how to play golf. And then they would work till about 8:00 at night. And I had a young kid at home, and I kept saying, guys, I don't want to go hit golf balls at lunch. I need to get done with work so I can go home, because my wife is home with our newborn, and you're killing me here. So blessing and the curse. But no, in the Asia world, I was introduced not as my title for what I did. It was that I was a good golfer, and that's sort of how I was introduced. So
yeah, me too.
That was your call sign in certain circles.
Exactly. Okay, so at what point did you start Montgomery Technology? Can you tell that story?
Yeah, for sure. So I was working kind of sort of this property management and technology role, and a friend of mine was involved in sort of this transition of the riser management world and with Montgomery Technologies, and I joined to run the operations for Montgomery Technologies. And this was back when sort of right after they deregulated telecom, and in certain markets, California, Illinois, and others, the landlord declared EMPO, which meant that the phone company no longer controlled the infrastructure that ran from the basement of the building or the mainframe of the building and the EMPO up the riser. So riser management really was designed to help the landlord manage the liability that was suddenly there since they inherited this copper infrastructure. That copper was installed for by the phone company and managed by the phone company since inception. But as they deregulated, they started to peel that back. So our job was to work with the commercial real estate owner to manage the riser infrastructure. And historically that was copper. But as we sort of saw things move from copper to fiber, there was a dramatic increase in the demand for space within the riser and the infrastructure to support the tenant telecom needs. So we sort of had a front stage view of what happened as technology went from copper to fiber, and from the old days of T1s all the way up to now where we're doing fiber circuits, gig circuits, 10 gig circuits. So all of that has sort of happened in the same envelope in a commercial office building, which is the telecom riser. And that infrastructure is something that Montgomery Tech has been managing now for 20 something years. So that's kind of how our introduction to commercial real estate started. And that's really the background from which the lens that we're looking at is really from the landlord side of the house, from an infrastructure side, and how do we get the tenants what they need from a technology perspective in the context of a commercial real estate building.
Got it. Can you explain how it worked before this riser service came to be? Like when the telecom companies pulled out, what were they doing before and why did they pull out?
They were sending their own technicians, and the way that it was typically worked was it was all copper. So you had kind of a 1-for-1 for each phone line. There was a copper pair,
Okay.
And the phone company would have technicians that would go do the cross connects. Some larger buildings had their own on-site staff that would do cross connects, but as they deregulated and they handed it back, the phone companies started to pull back a little bit on their staffing, or the landlord started to insert themselves or had to insert themselves in this role. So when the telecom company didn't do it, the tenant would hire whoever they wanted to go and do the installation. And the landlord suddenly had this problem where they would have multiple people coming into the building working on infrastructure that was shared. So riser management was really to manage that. So only certain people were doing work. So you didn't have a situation where you're going to, do work for a tenant on one floor and you take down tenants on floors above and below. So really riser management was sort of that, how do we manage the shared infrastructure and how do we do it in a way that's, reduces liability and is cost effective for all participants, tenant, service provider, and landlord. And that's really kind of where we've been sitting ever since, is that intersection between landlord, tenant, and the service providers. And that now applies not just to telecom, but also to, building solutions as well as cellular or DAS, as we're going to talk about a little bit later.
Yeah, totally. Can you just give a general overview for people that aren't networking folks like me of when you say telecom and building systems and wireless, how all these systems are different and what payloads, for lack of a better term, go on each of these systems? Is it all IT, phone type of things, or is it all OT? Can you talk about what goes on what types of systems?
Yeah, so that you've got a fundamental telecom need in commercial office buildings that is distributed by the telecom providers. It typically runs up the building riser into the tenant space, and that's how the tenants get their voice, data, and internet for their services. The landlord is often sort of passive in that role. They provide the space and allow the tenants to contract with the service providers, AT&T, Verizon, Cogent, at all Lumen, that provide those services. So that's the telecom side. And the base building systems is typically a separate set of network infrastructure that, and you've talked about this a lot on your podcast about the various silos for building systems. So there's the BMS and access control and metering, and all of that infrastructure is often separate. And whether it's physically separate in a different telecom chase, or whether it's physically separate in an electrical riser, but that's infrastructure that runs throughout the building to support the OT side of the house. And obviously with convergence, there's been a transition and a kind of a convergence of OT and IT, but from a physical infrastructure, it's still relatively siloed. And then the new participant in this is wireless. And how does wireless play in this space? And wireless from a cellular perspective versus Wi-Fi and other technologies all have different infrastructure. So what we're finding in commercial office buildings is that we have more and more networks in the building, and there are various stakeholders that are using the systems, that are relying on the systems, and more importantly, are owning and paying for the systems. And it becomes a big challenge from a riser perspective. How do you manage all of these competing interests in a finite amount of space that is not getting any bigger? And as we've noticed in new design, the space for telecom gets smaller and smaller. The architects are designing closets, IDFs, to be as small as possible because it's not rentable square footage. So we're doing much more technology with less space. So we have to be more efficient in how we use it.
Got it. Got it. So can you talk about, just like, we're going to go deep on wireless. That was kind of setting the context there. We're going to go deep on wireless. Can you talk about just general trends in wireless connectivity today?
Yeah, I mean, I think obviously the biggest trend in wireless is 5G, which is going to be everything for everybody, or we don't really know, because it sort of becomes the panacea that's going to solve all ills. And what we're all realizing, we're thinking that, well, like, instead of running a cable, I have a wireless connection. So all I need to do is connect. And that's true. We now notice in our offices, we used to run, 2 Cat 5e or 2 Cat 6 cables to every location, and we plug into the wall and plug it into our computer. Most of us don't do that. We basically drop our laptop on our desk and we connect to the Wi-Fi, the wireless access points that are in our system. So we sort of feel like wireless replaces wires, but it's wireless to a point. And there is always a wired connection somewhere in the building and somewhere in the space. So, for many people, they think wireless is everywhere and they don't understand sort of how it works. But it is important to understand that it's wireless to a point. And then from there are electronics and equipment that take that connection out to the network and then ultimately out to the internet. So we sort of see it from one perspective, as I don't see wires anymore, but in the back end, there's lots of wires, and there's lots of different wireless connectivity and frequencies and technologies that are supporting building systems. So the term wireless can refer to a number of technologies. And I think that's where people get confused in terms of what is wireless cellular versus Wi-Fi versus LoRaWan, or other protocols that are being used to transmit data wirelessly.
Totally. Yeah. And I think that the premise for this conversation, what I'm hoping to get out of it, is kind of like just a general understanding of how each of them are different and where they play and that kind of thing. So let's walk through a couple of them. Which one do you want to start with?
Well, I think the one that is probably the one that most folks are sort of trying to figure out right now is cellular. And we can talk a little bit about cellular and explain sort of the history of cellular in commercial office buildings and some of the solutions that are out there. And then we'll introduce the term DAS, which stands for Distributed Antenna System. So because we're all using our cell phones so much, maybe it's useful to start there, because we've all have this expectation that I can now use an app and I can manage my building systems, or check my email, or watch TV or what have you. But historically, in a commercial office building, wireless cellular service wasn't something that you needed. You would use your cell phone when you were commuting to and from the office, and then you would pull up into your building and you would go to your desk and you would use your desk phone. So initially, we didn't really have a need for cellular in our buildings. And when the cell carriers designed their networks, they didn't factor covering buildings. The goal for cellular initially was to cover people that were mobile, i.e. in their cars, on the street, and it was designed around that use case. So what we found is that historically we didn't really need cellular in our buildings. That obviously has changed, and as the demand grew for cellular and the applications grew, we started to see this need to get cellular into buildings. So the kind of the start of this, where it was, I trace it back to my first experience was right around 2004, 2005, where you'd have large enterprises that were using and doing billing, like law firms or accounting firms, using their BlackBerries, and they wanted to make sure that their their staff that would be in and out of the office could be billable at all times. So they would put in a cellular system in a building to enhance the signal so that they could use their BlackBerries and always be connected and always be billing. And that was sort of where we saw that begin. And then it obviously, with the iPhone, the whole industry sort of changed dramatically, because now all of a sudden, I didn't even want to use my desk phone anymore. I wanted to use my cell phone. It could do so much for me. And that's when we really saw the in-building space sort of explode from a wireless perspective. And that gave rise to the need to enhance cell coverage within a building. So that's kind of where we started. You know, we didn't design the carriers didn't design the network to cover the building, but now we're in the building and we want to grab it. And the way cellular works is your device goes to the signal that's strongest. And if the signal strength outside the building is strong enough, you can pull that signal from a neighboring tower. But as the signal degrades, your cell phone doesn't have the ability to pull that signal. So what has happened, and sort of the solution for that, is what we refer to in the industry as a distributed antenna system, or a DAS. And there are lots of different flavors of a DAS, but effectively what it is a system where the signal strength in the building is made to be stronger than it is outside, so that the users can use the cell phone and pull coverage from within the building without having to hit a cell site outside. So that's kind of how it works from a technical standpoint. There's lots of nuances and technologies around how that works and such, but that's basically what we're trying to do, is make it so that the users in the building can pull signal from internally and not go to a cell site outside. And that it becomes a technological challenge for all of us. And really what it has done is exposed sort of the typical split incentive challenge in real estate.
Okay. Yeah.
Which, you know, and the business side around DAS is very, very complicated. And that's sort of the hardest part. The technology, there's lots of great companies and smart folks that have come up with all sorts of great technologies around cellular, but the business side around it is very complex and difficult to navigate.
Before we go there, real quick, I just want to understand the technology side of things. So typically you'd have like a huge antenna on either a tower or on the top of an adjacent building or on the top of your building. How does the actual infrastructure work inside of the building? Is it like smaller antennas, like different types of equipment that they run a line to, and then, go ahead.
Yeah, that's a good question. I mean, so the way that a DAS typically works is you have to have a signal source. So you have to pull the cellular signal or create the cellular signal. So two ways to do it. One way is you put an antenna on the roof, like a donor antenna, and you pull the signal from a neighboring site, and then you distribute that through the building. And that is one way of doing it. The distribution through the building is either active or passive. Passive is done with coax and non-powered equipment, and active is done typically with fiber and electronic radio units that are then farmed out to antennas. The most common forms of DAS include some signal source, either a donor antenna or a base station, which is more advanced, and then a backbone, which is now almost exclusively fiber. So from a network standpoint, we have this base station where we generate the signal. We have a fiber backbone that extends up that same riser system. We have electronics that convert the fiber into the RF source. And then we have antennas that are hung off of that unit that go out and provide the coverage throughout a floor in a commercial office building. And that's the design, and that's how it works. But as you can imagine, in a 50-story office building, I have base station equipment, I have fiber backbone, I have electronics on, every 2 or 3 floors, and I have antennas, 10 to 12 antennas on every floor.
Wow.
So it's a massive undertaking from an expense perspective. And that's just to get, one carrier on one frequency. So you take that and you need a base station for each carrier, and you need antennas and or equipment that supports each carrier. So the amount of infrastructure required for a neutral host DAS that can support three carriers is quite extensive and very, very expensive. So that's really where the challenge has become, is we're asking, competing companies to share infrastructure. You're asking landlords to participate in this, and they don't make any money. When you pay your bill to Verizon, they don't say, oh, and let's pay a portion of it to the landlord that funded the DAS in their building.
Right.
That doesn't happen. So the incentives aren't necessarily aligned. So that's sort of been the challenge that we've had in commercial real estate, is who owns the system, who pays for it, and how does it get managed moving forward? And that's where the DAS industry has gone from, different models that have evolved over time to the current model, which is the carriers are really not participating very much from a cost perspective. They're certainly not paying to be on these systems and not paying any rent. The carriers are basically telling landlords, and the industry is telling the landlord, if you want cellular for your tenants, you should pick up a big portion of the bill. And that's kind of where the industry has settled on. That's the current state of affairs and again, I'm referring predominantly to multi-tenant commercial office buildings. The calculus is different for the carriers in public venues, in other environments, but really,
owner-occupied buildings or institutional buildings, those types of things.
Yeah. So this is sort of the lens here is commercial office and typically mixed multi-tenanted space. So that's kind of where we are. But the reality with DAS is that, conceptually it makes a lot of sense, right? You need cell coverage everywhere. There's a finite amount of space. If you can do a system that is neutral and can support multiple carriers and cover all of the floors, then that's the most efficient use of capital to get full coverage, to satisfy everybody and get everybody sort of sharing in the cost. That's the concept, but the reality is not everybody wants to participate at the same time. Not everybody is interested in that particular building. Example, if I'm T-Mobile and I don't have any enterprise customers in the building, I don't even think about that building as being anything I need to cover.
Mm-hmm.
And if I'm a landlord and I build it and T-Mobile doesn't want to participate, I can't make them. It's their signal. They own it. So that's part of the challenge that we're seeing in the space, is how do you get everybody on the same page and how do you get it funded?
Absolutely. But the value proposition is, if I'm a building occupant and I walk into the lobby, I haven't connected to any Wi-Fi networks yet. Maybe it's the first time I'm there. I just have an expectation that I can make a phone call. That's the main value prop?
Yeah, I not only make a phone call, but I can stream. I've been watching a movie on Netflix, and I have my headphones on, and I walk in off the street, and I've got the movie playing, and I want to watch that all the way up to my desk, and I expect that that's going to work.
Yeah. Uh-huh.
And if it doesn't work, who am I going to blame? Is it Verizon or AT&T's fault? Is it the landlord that's supposed to provide that for me? Is it my employer? So the expectation is that cell phones are going to work everywhere. But the reality is that it costs a lot of money to deploy cellular networks everywhere. And who's going to pick up that tab is sort of the question that we're all sort of grappling with a little bit.
And so what sort of models are you seeing for who picks up the tab then? I mean, the first thing I thought of is a landlord passing that through to the tenants in some way?
Well, that's a great question. There's a couple models, in some cases, and for certain strategic assets, if there's, big enterprise customers, sometimes the cell carriers will want to cover them. They're doing a national deal and they'll provide coverage for, an enterprise customer in that building. Some landlords got out in front of this when the carriers were footing the bill. And the carriers, you remember, back in the day when the advertisements were people competing, my coverage is better than yours. And I even remember there were ads about, when AT&T was investing heavily in building, where they would have the guys in the building popping ceiling tiles and talking about the network in the building being better. So there has been a competitive drive for the carriers, and there are still some cases where the carriers will fund it. There are third parties that, that are, remnants. A lot of them are tower companies that installed and owned and operate, these systems in the buildings, and they're basically getting the carriers to pay just like they would on a cell tower, and they're installing these systems in the building. So there are funding sources there where they will own and operate the system, and in some cases provide the landlord with some rent. And that's kind of where the industry was for a while. Landlords were saying, what am I going to get out of this? I'm going to let somebody put all this infrastructure in my building, and they're going to provide services to my tenants. What's in it for me? How do I get compensated? And that was the business model. And the carriers played along for a while, but then the carriers basically said, no, we're not doing that. We're not playing that game. We've got so much money invested in buying new spectrum. We're building out fiber throughout our network, and we're doing this massive 5G upgrade where they're upgrading all of the cell sites outside the building. So the in-building space is right now in a position where it's not getting a lot of attention from the carriers from a funding perspective. So their perspective right now is a little bit more of, if you pay us, we may give you a signal source, but that's about it. But if you want to do it, you should pay for it, Mr. Landlord.
Got it. Okay. And then where are we at from a, like, what the tenants want perspective? Like, what do they expect? I know that's a really blanket question in terms of it's probably not the same in all markets, but what are you guys seeing with your clients?
Well, what we're seeing, and this is kind of where Wi-Fi comes into this. What we've seen is that most of the tenants can't really wait for the carriers or the landlord to solve for this. So historically, tenants have taken care of all technology in their space anyway. So for most enterprise customers, they're putting in an enhanced Wi-Fi network. They're leveraging their own Wi-Fi for Wi-Fi calling. So they're basically taking that out of the hands of the carrier, because it's a much more complicated transaction. If I'm an enterprise customer, I can put in Wi-Fi. I can set the security standards for that Wi-Fi on my own, so I can have some of that network security, and I can take care of my space. Can I take care of the lobby or the transition from the lobby to the elevator? No, I can't. Is that a big deal? For some, but for most, you're worried about people working in your space. We are seeing a lot of landlords invest in Wi-Fi outside of the tenant space, amenity spaces, lobbies, rooftop decks. Landlords are investing in Wi-Fi to provide coverage there, because the beauty of Wi-Fi is I don't need the carriers to participate. I get an internet circuit from who's ever in my building, and I distribute that Wi-Fi within my space. And that's why you see that the penetration of DAS in commercial office is less than 10%, but the Wi-Fi participation is, every building has multiple Wi-Fi networks. As we all know, as we try and pick up a Wi-Fi network, there's about 15 or 20 that pop up on our phone. So people are solving this with Wi-Fi, and Wi-Fi is getting faster and more secure. So that's kind of been the solution for a lot of tenants and a lot of landlords that said, I can't really get a DAS. I can't control that transaction because I can't control the carriers, but I can control the Wi-Fi elements of it. And that's what we're seeing a lot of people use as the solution.
Got it. And I'm hesitant here because I feel like a lot of people know how Wi-Fi works, but we do want to just take that as our next category then and go do a little bit of a deep dive on how that works, what the different infrastructure pieces of it are, and then how is it handled from a landlord tenant perspective. I think you covered that last piece already.
Yeah, I mean, from a Wi-Fi perspective, you're distributing the signal. You're distributing a signal, but the signal that you're distributing is really you can control that. You don't have to ask the carrier for permission to broadcast. You're basically broadcasting in a frequency range of, and you're able to distribute that based on the number of antennas that you deploy. And most of these systems are now advanced. They're cloud operated, so you're using advanced technology to figure out how many wireless access points you need. And there are more and more security built in, so the network can be secured. The concern with Wi-Fi was always sort of that public Wi-Fi where you log in and you're concerned that somebody could steal your traffic or such. But in a commercial office space, the IT department and the ability to secure the Wi-Fi is sort of a bit more managed. There are lots of challenges with Wi-Fi in terms of oversaturation, and where you've got congestion, and managing multiple Wi-Fi networks in a commercial office building is a challenge. But the reality is the landlord is not really in a position to police that, because each tenant is responsible for their own lease space. So as a landlord, getting involved in policing people whose Wi-Fi coverage is dropping 3 floors below and above is really not an area where they, really have much ability to control that. So I think Wi-Fi continues to evolve, and we're seeing Wi-Fi replace a lot of the cabling in office buildings. And so we're seeing it from that perspective, and we're seeing it broadly as an alternative to DAS, because the DAS distribution is so much more expensive, and Wi-Fi is relatively inexpensive. You do not need a base station. You take your existing internet circuit, you have a power over Ethernet switch, and you have an antenna mounted in the ceiling, and that's it. Relatively straightforward.
Mm-hmm. Can you talk about Wi-Fi from the standpoint of connecting sensors, connecting thermostats, connecting all types of what used to be OT systems that were hardwired on, then they're now being connected more and more onto Wi-Fi networks? Can you talk about that trend? Is that creating any challenges, or what are sort of the trends there that are happening in that?
Yeah, regard? I mean, it's creating some challenges, because the manufacturer that's sort of speccing the equipment is putting in the frequency that their device will pick up, and there's no real testing to determine whether that frequency is congested or is available in that particular building. So you're on the 2.4, that's all you've got. You plug it in, and you've got such saturation that your lighting control system can't find the network. So there are elements of that are out there. We see landlords where they can't get a DAS installed. We do a lot of Wi-Fi for common areas for engineering. So we create wireless networks so that the engineers can, get a connection to, do work order management on a tablet and things like that. We see sensor data. We see a lot of companies deploying cellular because they know they can purchase a card from Verizon and be able to get a connection, hopefully anywhere they want. The reality is, if they're in a building where there is no cell coverage, it's not
back to the previous.
And you usually don't know that until you deploy it. So, I'm speccing an equipment. I have a card with Verizon. I'm deploying that network, and it's going out to a local integrator that's installing it. And if the coverage isn't sufficient, what do I do then? I can't really solve for that locally. So
I did want to ask you about that. I'm glad you brought that up. Around a lot of vendors, that's their preferred, smart building technology, IoT vendors, that's their preferred connectivity method, because they feel like it takes the IT, big headache out of the equation, right? We're just going to connect. We just know we can do it. What does that mean from a security standpoint when you have a bunch of different cell cards strung throughout the building? So you mentioned it from a reliability standpoint, but what about a security standpoint?
Well, from a security perspective, the LTE and the carrier networks have network encryption. So from a security standpoint, the network is secure, arguably more secure than a public Wi-Fi connection. Okay. You can create a Wi-Fi connection that is secure to support that same device. But your problem or your challenge is that you're going to have to interface with somebody at the building on an IT level. Yeah. And that brain damage for that, if I'm the supplier, is often a big challenge. So I would rather just rely on a cell card to do that. Now, the coverage on those cell cards, and we have this happen all the time, where folks have cellular modems distributed throughout a building, and the connection is spotty and the data doesn't flow. Yeah. That's just the reality that we're living in. So having a wired connection and having that device connected to a hardwired connection with a VLAN and good bandwidth is preferred. It's just harder to maintain. But I think as buildings, move towards converged networks and have provisions for connecting devices, I think, we'll be wireless to a point, but we're going to, ultimately there's going to be a connection there. And I think that, we'll see that continue to evolve. In a lot of cases, the provider doesn't think the landlord has any network at all and doesn't want to jump on another network because it requires them to coordinate with, to share infrastructure and to coordinate with folks, whereas the cellular device is relatively standalone.
Mm-hmm. Yep.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview.
Okay, cool. What's our next technology you want to unpack?
Maybe we can talk a little bit about CBRS,
Okay.
which is a spectrum that the government released for use for wireless connectivity, and it's localized to a building, so you can use this network within your building. So it's an incredible opportunity for landlords to get spectrum that they can use at their building. The challenge that we're facing with CBRS, and the distribution is similar in the sense that you've got antennas connected to wired devices, to switches or devices that are back to a head end. The signal source is not required to be provided by others, i.e. the cell carriers. You're basically connecting it to the cloud, and it's got some great potential. The challenge right now is that we just don't have, we don't have the ability from a business perspective to really monetize it. So, people would say, well, it's great, I can put in the CBRS network, and yeah, I can use it for base building connectivity, but how many of my vendors and systems and IoT devices can function on CBRS right now? Not a lot. And if you're talking about using it for cellular, if I can take the traffic in the building, I have to hand it off to the cellular network at some point. And if I can't hand it off to Verizon or AT&T or T-Mobile, then it's going to die in my building, which doesn't really help me from a cellular perspective. So I think CBRS is a technology that has tons of promise, and it's exciting because it's localized, but it puts a big onus on the landlord to understand the technology. And since there's no real monetization around it, that's where the business side of it comes into play, where you're telling the landlord to invest $1 million in putting in a CBRS network without an ROI. I think most of them are going to pass on that until it's more fleshed out.
Yeah. What are the potential ways in which they might get compensated then? There has to be ideas, because I've seen a lot of hype around CBRS.
Yeah. I mean, part of it is the cellular carriers, paying, for the handoff, and that's kind of the question is, ultimately the cell carriers are the only one that are benefiting from people using their network. No one else benefits from that. So if you're going to expand their network in your building via CBRS or a DAS, are they going to get a free ride because you have to provide it because your tenants expect it, or are they willing to pay for it? And they don't have the capability to, the scale to put in a system in every commercial office building in the world. There's no way. So there's got to be business models and ways to hand that traffic off. And there are some, but they're just not mature enough where people can, make a compelling argument from an ROI and do it at scale, where an owner can go do it in, 50 buildings across the country and know that they're going to get a return on that. So, lots of people are trying to figure that out. And I'm not sure that it's going to be solved anytime soon. I do know that the technology is exciting, and a lot of this technology is exciting, but exciting technology in commercial real estate always has a bit of there's always a clash there, because landlords inherently are out to make a profit, and every dollar they invest in the asset adds to the value of that asset, and every dollar that they spend operating that building has an impact on their net operating income, and a building is valued based on its net operating income. So if I'm incurring a bunch of additional costs, I better make sure I'm getting some value from that. And that's, that comes back to sort of the core of commercial real estate is making sure that it can pencil for the landlord.
Yeah, totally. couple of high level questions before we move on from that one. What does the acronym stand for? First of all,
For Citizens Band Radio Service.
and then I just wanted to circle back on can you restate how CBRS and DAS are different? I'm still learning all of this.
Yeah, no, no, it's so for DAS, the frequency and the signal strength, the signal itself is owned by the carriers. They have the FCC license to operate that frequency.
Okay.
So you have to ride on their network. With CBRS, that spectrum is granted to the operator at that localized location.
Okay.
The government grants you the right to use CBRS spectrum in your building. And there's a whole business model around how you register your spectrum, how you monitor your spectrum, how you report your spectrum. So there's an entire ecosystem that's evolving around how you register to get your spectrum.
Okay.
And then, so that's sort of why it's a bit in its infancy. If I contrast that with Wi-Fi, I can go buy wireless access points. I can run a cable to my switch or my router, and I can basically manage that out of the box very easily. Whereas CBRS, I've got a lot of extra work to do.
Yeah.
To get it to work. And that's sort of why we see Wi-Fi adoption so much greater than anything else, because the control can be localized to, per user, per tenant.
No, CBRS, they might be able to have their own spectrum, but then at some point they then need to, you're saying, pass that traffic over to the carrier to complete.
Unless if I'm an operator and I want to have my own spectrum and I want to use it, and CBRS is a little bit, has some security advantages over Wi-Fi, I would use it instead of Wi-Fi. I would use it for, digital signage. And, there is thought, James, that, for base building systems, that's what people are going to want to use because they can keep it localized.
Okay.
Maybe that's where it goes, but I think it's a little bit too soon to tell. It is nice that it's localized and I can control it and I own it at the building level. I'm not relying on, third parties or multinational companies to control the spectrum in my building. I can control it. But as a landlord who hasn't really gotten that deep in technology for most things, maybe I don't want to own and control that.
Yeah. Yeah. At least until you're saying more infrastructure is built up around it and monetization. Yeah, happens. Okay. So what about 5G then? Where does that come in?
Well, 5G has, tremendous promise from the advantages of 5G are much higher bandwidth. So we can do much more with our devices that are connected to 5G and lower latency. So, it will be a game changer from a technology perspective. The challenge is that, we talked a little bit about the cost of deploying DAS, and the challenge with 5G is it requires more density. So it needs more antennas. The frequency doesn't go quite as far. So I really need to increase the amount of infrastructure I install. So one of the big challenges we've had for DAS deployment has been the cost. So, there are elements of DAS deployments that the cost has come down, but, like anything, if I add more antennas, then that means I have more technicians running more cable, installing more antennas in the ceiling. And in a retrofit environment, that's after hours, that, there's all sorts of stuff that goes along with more installation. So that's kind of one of the challenges. And the other challenges from a carrier perspective, where they're funding right now is 5G outside of the building. So, we'll see 5G, it's happening right now. A lot of the cell towers are being upgraded to 5G. The devices are being upgraded to 5G. So it's happening, but the in-building space is not necessarily, at the top of the list. The in-building space has been, again, with the exception of public venues or hospitality or things like that, commercial office is sort of, not at the top of the list for when they're going to get their 5G upgrade. And then again, who's going to pay for it? That's the question is the carrier going to participate in the fact that they're going to be able to provide more bandwidth and potentially make more money? Or is that the responsibility of the landlord to make sure the carriers are making a lot of money? I think some landlords have a problem with that.
Got it. Yeah, you see, in terms of everything we've talked about today, 5G is something you see so much hype and advertisement and hoopla around, right? At this point, where are we at in that sort of hype cycle for 5G?
I mean, it's happening, and it's kind of like I mean, part of it's a marketing thing to get you to buy new devices, and we're seeing it. But from a deployment standpoint in a building, what it does mean from a landlord perspective and from an integrator perspective is if I'm putting in a system right now, I better make sure I have a migration plan for 5G, and that's kind of where we do have that example when the carriers went out about 10 years ago and installed these DAS systems. Back then they had multiple frequencies they were supporting, and they had different head end equipment for each system, so it was very expensive to add all these sectors. When you go to 5G, what does that mean? Does it mean I have to rip and replace everything I've already installed? Like, how do I get from 4G LTE to 5G to potentially whatever's next? What does that require? And I think from the manufacturer side, the goal is to make it so that it's software defined changes, so that once you've installed the infrastructure, i.e. your fiber and your electronics, it's a software defined change. So it's not rip and replace and new antennas everywhere. But that's sort of the challenge. What I think what 5G is doing for a lot of landlords, it's like most things with technology, it's creating confusion.
Yeah.
Leads to an action like, shoot, I don't want to install the wrong thing, because the minute I do this, I'm going to have to upgrade, and where am I going to be now? So I think it does, it's sort of a victim of its own hype, where people are kind of, going to wait it out. So I think the jury's, it's happening. It will happen. We're not going back to 3G.
Yeah.
But how it gets deployed, and again, who pays for it is, will be something that we'll probably be witnessing for the next couple of years.
Yeah, totally. Okay, I think this is the last one, but I wanted to ask you about LoRaWan. So LoRaWan, I know, is not very prevalent from the standpoint of your customers, but it seems like it's showing up kind of like we talked about earlier with the wireless sensors and thermostats and things, showing up more and more on the vendor side of things, right? So I'm trying to install a new IAQ sensor network, and it's going to connect to itself and then connect to the cloud via LoRaWan gateway. Can you kind of talk about this and how it's showing up these days?
Yeah, I mean, I think what we're all, on the internet and back on the building system side of the IoT world and all the hype and all the cool technology that's supporting sensor data, I think, getting information from a sensor to a gateway and then ultimately to the cloud is super exciting and compelling, and is going to change the way buildings are managed. I think the LoRaWan example probably will find its footing predominantly in single-use owned facilities, distribution plants, factories, and other things where it's not a multi-tenant environment, where the owner operator is willing to make the investment in the technology because they see the benefit. So the business case for LoRaWan will be, how do I operate my factory or my logistics plant more efficiently? And that technology, when you compare it to traditional wired technology, has some cost benefit savings for it. In the commercial office space, maybe bits, parts and for the mechanical rooms or the cooling towers and such, but broadly throughout a commercial office building, introducing another technology in the building and another siloed network is probably going to be a bit more of a heavier lift. That's why what we're seeing on the building side is the more we can normalize the transmission to be Ethernet, IP based, the more we can layer on different systems. So we're seeing, everybody sort of using, moving to IP as the standard thing. And we're seeing wireless more and more, but it's wireless to a gateway.
Yeah.
The gateway has an IP connection, and then we take it from there, throughout the building and out to the cloud and the rest of it. So I definitely think there's applications for lots of these. There are lots of other wireless protocols designed to mitigate the amount of wiring, but I think we'll see them have certain applications, but maybe not as broad in the commercial space as others.
Got it. Okay, can you sort of summarize then everything we just talked about? So we talked about all these different technologies. Where would you, I guess, well, what I want to get to is how do you get started? How do you think about like how to make decisions in this environment? But first, can you sort of summarize kind of where we're at as an industry with all these different technologies?
Yeah, I think where we are is obviously, we're all using our phones much more than ever. We want everything on an app. We expect our phone to work wherever we are, and we want that mobility play. So what does that mean for a commercial office owner and operator? Do I need to put in a distributed antenna system? How do I do that? And is it something that I'm going to pay for? Are my tenants going to participate in that? The leasing environment is changing. Obviously we're all, kind of very cognizant of what's going on in commercial real estate. How are we going to get tenants back to the office? How are we going to make our building more desirable? So for some landlords, making sure there's cellular everywhere is going to be table stakes. They have to do it, and they're going to make that investment. For other landlords, they're going to basically push it back to the tenant and say, solve it for it on your own. And we have a hard time corralling the carriers, so we're not going to do that. So I don't know where that's going to end up. I do know, for new buildings, the cost of deploying a DAS at a new build is a little bit less expensive than a retrofit, which is really, really expensive. And, some of the new building materials like low E glass really make it difficult for the signal outside the building to get in. So we can't really rely on the macro network to solve it. So I've seen in a lot of new developments where a DAS infrastructure is either installed, or at the very least, the infrastructure requirements are met, i.e. conduit, space, and a conditioned room where the equipment could go, and or space on the rooftop for antennas. So I think, smart landlords are designing in, the flexibility from an infrastructure perspective to accommodate these technologies. But it's difficult to, bet on a technology when you're not sure which way it's going. And also it comes down to who owns it and operates it. If I'm a commercial building owner, I don't really want to own and operate a wireless network in my building. I may not have the staff to do that. And that's not something that I want to take on from a liability standpoint. So there's lots of questions about that, but I do think that, cellular in the building is something that tenants expect, people expect, and whether the tenants are going to help pay for it via, CAM charges, or whether they're going to pay for it installed in their space is going to vary based on tenant lease terms and where you are in the cycle.
So as far as the different technologies we talked about, it sounds like Wi-Fi is happening no matter what.
Yeah, Wi-Fi is happening. You're going to have Wi-Fi, in most places. The tenants are going to have Wi-Fi on their floors. Landlords are going to have Wi-Fi for common areas, engineering, and other locations. So you're going to have Wi-Fi. Whether you can eliminate Wi-Fi by having a DAS, it's not an either or. It's probably an and.
Yeah. If you can make the business play fit. Got it. Cool. All right. Well, thanks, Greg. I feel like I am primed. I'm caught up on all the different happenings in CRE office wireless. Thank you.
Yeah, no, and I think one of the things that's interesting, there's lots of companies out there that are doing distributing these solutions and trying to figure out a way to make it work. The costs, are coming down a little bit, but it's still, our barrier to entry here is the cost of deploying these networks is still pretty significant. If it's $3 a foot to just deploy a fully, full neutral host DAS, that could be a significant barrier for certain building owners.
Absolutely. And then what about the management of it as well? How much are people costing or spending in terms of the ongoing maintenance of a system like that as well?
Pretty significant, depending on you've got backhaul, and you've also got the monitoring and maintenance of the equipment. So you're in for $5,000 to $10,000 a month, and if you take that at a cap rate, that's a pretty significant hit to NOI for some buildings. For other buildings, it's not much, but the sensitivity on that will vary based on landlord. And again, in some cases, tenants won't lease space. They say they won't leave space without it, but ultimately the real estate decision comes down to a lot of factors, and not just, one or two. So
Yeah.
it's hard to say how much it translates into lease rates. That's the argument that everybody always makes when they're selling something to a landlord. Oh, you can increase your rent. Okay. How do you know that,
Mhm. It's not just about that one factor.
Yeah.
Got it. Well, always a pleasure to chat. I'd love to end with some carve-outs. So we've been doing this for the last 6 months or so. Any books, podcasts, TV shows, movies you'd recommend people check out? Could be personal or professional, wireless related or not.
No, I'm actually watching, I'm watching We Crashed right now.
Okay. Yeah.
And it's fascinating because we sort of lived through the whole WeWork.
Yeah, I'm sure you did.
And we actually, at one point, we were in a WeWork office in New York for a while, and to sort of see it and all of the questions that we were asking of, how does this pencil and how can this possibly work are being borne out in the series. So it's pretty interesting to have lived through it and to watch it. And it's also fascinating. It does, highlight sort of technology and commercial real estate and how, for WeWorks, all of the, ills you can say, what it really did was, really helped landlords understand that tenants, want the space, and getting a lease and getting a space fit out and getting the technology and getting all that in a commercial office building is really very, very difficult. And most companies want, simplicity around that. And that's why you see, while WeWork is sort of evolving and changing, a lot of landlords are doing their own co-working and are using technology as a differentiator and as a way to legitimately charge more rent. So they took the examples of WeWork and are using it internally to make their spaces more desirable, shorter term leases, more rent and all that. So I think it is interesting, sort of having lived through it, to kind of watch it back and to kind of be a fly on the wall to see what was potentially going on inside that office. Well, we on the outside were going, what are they doing? How is that going to work? How can they pay that much? All that. And it's, it didn't work from some perspective, but it did push the industry in a direction that I think is easier for tenants to
absolutely
get their arms around.
Yeah, I watched the first 3 episodes, I think, of that series, and then I kind of got like a little bit sick of the characters, even though the acting is incredible on that show. I just kind of got a little bit sick of them. I'll probably return back to it at some point. I'm going to take us in a different direction. So I've been gardening. It's like spring has sprung in Colorado here right now, which when this comes out, it will be like midsummer, but just pretend it's spring, people who are listening to this. And I got this, we'll put the link to the show notes. It's a worm composting bin with holes in it. It's called Sub Pod, and you bury it in your garden. And then the worms, eat your food, break all your food waste down, and then they swim back out into your garden beds and fertilize, and then they come back for the food every day. It's really genius.
Wow.
Genius design. And then there's a Netflix recommendation I would recommend to go with this. It's called Fantastic Fungi. It's a documentary. Everybody should check it out. It's mind-blowing. That's all I'll say. I'll just leave that for people to go. Just trust me. Go watch Fantastic Fungi.
Nice. Well, we watched Biggest Little Farm, and then I convinced my wife that we needed chickens to change our soil, and then the chickens brought the rats, and we wanted to get an owl box. So all that stuff played out in a residential neighborhood. Didn't quite work out so well. So we went down that road for a while, and have now gone back to basics and have scrapped that. But do have the compost bin that we are using.
Nice. Yeah, I'm keeping it very, very basic. Couple worms, pile, couple gardens, little tomato action going on. That's it.
That's great.
So, all right, Greg. Well, thanks for coming on the show. I appreciate it.
Thank you, James. Appreciate it. And thanks for all you're doing to help educate and enlighten us on all this wonderful technology that's impacting commercial real estate. So thank you. And for everybody that's participating in your community. It's awesome.
My pleasure.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.